Here are your solutions to 9-2. We'll start with letter A. They ask us to refer to the scatter plot about yearly points scored by a certain race car driver. So here's the points earned, and this is the years since 1999 for the race car driver. Letter A asks us to draw and assess a line that seems to best represent the data. So once again, we're just going to turn on answers here. And I want to talk about this a little bit because I would disagree to a certain extent with this line. First of all, notice that we're going to ignore this point down here because it is an outlier. But remember, when we're drawing our line of best fit, two things that the book tends to do. They always draw the line through the first data point, which is not necessarily something that you ought to do. And secondly, they say that you're supposed to try and get the same number of data points above and below the line, and as you can plainly see here, we have 6 above and just 4 below. So I would draw this line more like through here, and you end up just a little bit lower. It's not that big a difference, but we end up with 5 above and 5 below. So for letter A, our sample answer would be that most of the points are not close to the line of fit. So in other words, when you look at this, if we clear everything out and you look at this, it's really not easy to see a trend here. At first, we're looking at it, and it looks like we have a trend going up if we look at these data points here, but then all of a sudden toward the end, so you could even kind of draw a line through it like this, and as you can see, you have about the same number of points above and below, so you really don't get a trend here. This is not a good set of points, and that's what the fact that they're not close to the line of fit is telling us. Letter B, use the line of best fit to make a conjecture about the points the driver will score in 2015. Again, we can recognize that this is not going to be very reliable, but if we use this line here, in 2015 we would have driver would score about 5,900 points, as you can see here. All right, let's take a look at letter C. The scatter plot shows the graduation rate of high school students. Write an equation in slope-intercept form for the line of best fit that is drawn and interpret the slope and the y-intercept. Again, this is going to be a difficult thing to do to get everybody to have the exact same answers. In fact, it's just plain is not going to happen. But that's why I've got the answers up right from the start here. Basically, all you need to do here, first of all, draw your line of best fit. And once again, I would disagree strongly with their line of best fit because they have absolutely no line or no points below it, and you've got 4 or 5 points above it. So I would say a better line of best fit would be more like through here, which of course is not going to change things very much, but I just want to make sure I point that out. So the next thing you need to do is you need to find a slope. So basically you're going to pick some spots where, and I like my line in this particular case here, I got kind of lucky. We can go from 60 right here, this point here, and if we go through this point right here, we have our line through 2 intersections. So if we go from 60 up to 70, that would be a rise of 10. And then this run from here to here would be from 0 to 6, which would be 6. So we have a slope of 10 over 6, whereas they had a slope of 3 over 2. If you divide 3 divided by 2, you get 1.5. Sorry, can't get that to work there. 1.5. And if you do 10 divided by 6, you get 1.6 repeating. So it's pretty close, okay? And now on my line here we have an intercept of 60, whereas they have an intercept of 59. So they're saying that the graduation rate is 1.5%. That's where this 1.5 comes from. And I would be saying that the graduation rate is 1.6 repeating percent. And that they say start out 59% of the high school students graduated in 88, and I would say that 60% of them graduated in 88. And then we're supposed to make a conjecture for the year 2020. Now remember, this is since 1998, so we have to add. So basically we're saying the year 2020 minus the year 1998. We'd have to go to 22. So if we go out here to 22, we would be plugging in that number. So we had 10 over 6. So first of all, I should go back. I never really told you what my equation would be. It would be y equals, we could reduce 10 over 6 to 5 over 3 x plus 60. So now we're going to take y equals 5 divided by 3, and then we're going to multiply by 22 years in parentheses, and then at the end we're going to add 60 to that. And if we do that, we get 96.6 repeating again. So our answer would be about 96.6%. Again, understand that because of the nature of this type of an assignment, we are not going to get exact answers here. Nobody's going to have the exact same answer, but everything should be reasonably close, within 5% or so, which this would be. Please do guided practice. Here are your solutions to guided practice, 9-2. Number 1, the table shows the life expectancy in years for people born in certain years. Okay, so the first thing we need to do is construct a scatter plot, which means plot the data. So we have one at 0 and 47.3, that's right here, one at 10 and 50, so 10 and up to 50, etc. And then draw and assess a line that best represents the data. Once again, they have most of the data points above and not much below. So if it was me, I would put a line of best fit in there just very slightly higher to put a little data above, a little data below. Not that big a deal. And then we also are supposed to assess that line, and we would say that this is a pretty good line of best fit. Everything is very close to the line, so we have a good model of the data. Then letter B asks us to write an equation, slope-intercept form for the line of fit, and interpret the slope in the y-intercept. First of all, make sure that we have our labels, and we need to find a couple of points where we have the line going right through an intersection, and I would say right here is one, and let's go up as far as we can. Right here we're awfully close to it as well. So our rise from 55 up to 80 would be 25, so we have a rise of 25, and our run from here would be 20 to here would be 100, so our run is 80. We can divide both those by 5, and we have 5 over 16, so we have 5/16. So we would have y equals 5/16 x plus our y-intercept, we'll call it about 48. And they say 3/10. So if you put 5 divided by 16 in a calculator, you get 0.3125. So we're very close to what they had. And if you wanted to use this decimal instead of 5/16, you certainly could. So there is our slope-intercept form of our equation, and then they asked us to interpret the slope and the y-intercept. The slope would tell us that for every year since 1900, life expectancy has increased by 3/10 of a year, or we would say has increased by 5/16 of a year. And then they actually forgot about the y-intercept here. The 48 means that in 1900, 48 was the life expectancy. And then for letter C, they ask us to use that equation to make a conjecture about the life expectancy for a person born in 2020. So since it's years since 1900, that would be 120. So we'll just do the math that they did for their equation. So we have 0.3 times 120 years plus 48 years. And 3/10 of 120 is 36 plus our original 48, and we have 84 years. And that's our answer, 84 years. And lastly, our essential question. Why do we estimate a line of best fit for a scatter plot? A good answer to that would be that a line of best fit helps in making interpretations and predictions about the situation modeled in the data set. So in other words, the better line of best fit you have, the more accurately you can predict further down the line. Like if we go back to that very first problem we had when we were talking about the points that a driver might score, we really were kind of guessing because it was really difficult to see where that data was headed. Whereas if we think about the second problem that we did, where we had a scatter plot of graduation rate for high school students, that was a really good line of best fit, and we could reasonably predict the future about what might happen with graduation rates. It's really important to understand whether or not you have a good line of best fit. Otherwise, we're kind of pretty much just guessing. Please do independent practice.